everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series, today in this video we are going to see a case study based approach for the topic positive definiteness in quadratic form. So as we know that there are three type of natures, which are positive definite, negative definite and indefinite in quadratic forms. So we are going to take this positive definite and we are going to see a case study problem. So first let us see what is quadratic form. So quadratic form are homogeneous polynomials of degree 2 in several variables. They appear in diverse fields such as physics, engineering, machine learning and economics for modeling complex systems. So optimizing problems, it is used for identifying maxima and minimas. Next, in physics, it is used for describing energy in mechanical systems. In machine learning, this is used in algorithms like support vector machines. First, let us define what is positive definiteness. A quadratic form q of x vector is positive definite if q of x is greater than 0. That is, for all non-zero vectors x, this property implies that the function has a unique minimum at the origin. That is, when we take a diagonalization process, after finding the diagonalized matrix, we get a matrix in which the diagonal values are positive. If all the diagonal values are positive, we call that nature to be a positive definite. If we have a 0 and 2 positive values in the 3 by 3 matrix, then we call that as a semi-positive definite or positive semi-definite. When we have all the values as negative, we call that as negative definite. If one is 0 and remaining two values are negative, then we call that as negative semi-definite. If or the eigenvalue consists of both positive and negative value, we call that as a indefinite. So here, first let us see geometric interpretation. So geometrically, a positive definite quadratic form defines an elliptic paraboloid that opens upward with its vertex at the origin. When we take an upward paraboloid, we have first quadrant. So in first quadrant, both x and y is positive. So the mathematical condition for this will be, for a quadratic form q of x is equal to x transpose ax, it is a positive definite if its associated symmetric matrix A satisfies a certain criteria. Let us see the problem statement. Here we are going to consider an equation 3x square plus 2xy plus 3y square. So determine whether the form is positive definite. So that is the problem statement. Here we are going to find the value which is positive or not. So here the method of solution will be, first we have to convert an equation into an matrix form. For that, if we have an equation ax square plus bxy plus cy square, that can be converted into matrix by a equal to matrix of a, b by 2, b by 2, c. So similarly here we are having 3x square plus 2xy plus 3y square. Here the a value is 3, b value is 2 and c value is 3. So on applying it in the above conversion matrix, we get it as a equal to 3 1 1 3. So which will be used to find the quadratic nature. So by Sylvester's criterion, for a determinant, when we take a minor 1 by 1 matrix, so we will have determinant of 1 which will be 3, which is greater than 0, which means it is a positive term. Next, by second, we will be taking the both 2 by 2 matrix, so we will get determinant of 3 1 1 3. On subtracting the opposite diagonal from the main diagonal, we get 3 into 3 which is 9 minus 1, we get it as 8, which is also a positive value. So since both the leading minors are positive, we call that to be a positive definite. Next is interpretation and conclusion. So here for q of x comma y plus q of x comma y equal to 3x square plus 2xy plus 3y square is positive definite. It has a strict global minimum at 0 comma 0. The value of q of x comma y is always positive for any x comma y not equal to 0 comma 0. So this forms corresponds to an elliptic paraboloid opening upward. Next is discussion and reflection. So consider these questions to deepen your understanding. If one eigenvalue was 0, so as we have seen already, if one eigenvalue is 0, it will be called as positive semi-definite. So indefinite forms means it will be having both positive and negative values. So if we have one eigenvalue 0, we have to see how the graph will be reflected, and even for the indefinite also. Thank you.